Hello everyone. So thank you, Valentina, to being here. Thank you, everyone, to join us today. Today, we will speak about test-driven development in some legacy environment with Valentina. First of all, I will present myself, and then Valentina, I will let you present yourself and speak more about you. For our part, I'm Arthur Magne. I'm CTO and co-founder at Promyze. At Promyze, we create some IDE and code review plugins that help developers and development teams to share their knowledge on best coding practices about architecture, test, clean code, security, accessibility, etc. by creating themselves their own best coding practices and discuss about them during what we call a practice review. Practice review is like a code review, but asynchronous, non-blocking, and with the whole team, not just one other people. And if you want to try it on your project, you can create an account for free directly on this link. If you didn't know about us, and we organize a lot of webinars every week about different subjects like domain-driven design, today test-driven development, and also technical dev management and the global team management. So first of all, Valentina, can you present yourself?
Yes. Okay, so first of all, I'm really happy to be here today and to talk about this topic about test-driven development in legacy code. And this happens to be very closely related to my main focus as a technical coach. So I work with companies, with their software development teams to help introduce hexagonal architecture, clean code, refactoring, and test-driven development to their teams in order to increase quality and accelerate delivery. And this topic today is definitely a common challenge faced by many companies, so I'm looking forward to this.
Yes, thank you. And for everyone, you can ask any question during this meeting, during this webinar, and you can use directly the chat or the question link that you have at the bottom right, and we will read. I will read those questions during this webinar directly. So feel free to interact and to ask any question. And first of all, at Promyze, we saw a lot of companies that wanted to push TDD to their team and failed. I think that they had a wrong idea about what is test-driven development and how hard it is to do it well in a legacy environment. So most often they had like a 2-day training session on kata or a new project or empty project. And just going back to their legacy environment was really difficult, and they never tried TDD again. So we saw a lot of companies trying to push TDD like that, and a lot of time the teams just say at the end that it's not possible currently with their legacy code. So maybe the first question for you should be, how do you introduce TDD, and why you should introduce TDD, and in which context, and what are the gain, and what are the return over investment of doing TDD on those projects?
Yeah, and that's actually a very good starting point because before even starting to introduce test-driven development into a legacy project, we should firstly evaluate what is the ROI of introducing it. So I'll now proceed to share my screen and to firstly answer the why question, and then we will also get to the how question, specifically also including that a common example that you gave of cases where teams try to introduce it and they fail, and we will look at the reasons why they fail and how to do it properly. So firstly, looking at should we introduce TDD in legacy code, let me know if you can see my screen.
It's okay for me, so I think
Right.
it's okay for everyone.
Okay, so here is a short summary of what is the ROI of even introducing test-driven development into a legacy project. So we have here two dimensions, features, and we have bugs. So the question is, in the legacy project, how many feature requests are there? Is this a project which is under very active development with lots of feature requests? Or is it a project where you get like one feature request a year and not much active development? And also, what is the business demand regarding release frequency? So the thing is, if you have more feature requests and a demand for higher release frequency, then that pushes us towards the higher ROI that you will gain from using ROI. So this is for more active developments, whereby if it's basically inactive project that is not being worked on, then it's lower ROI. So that's one dimension, the features. The other dimension is bugs. So what is the expectation from business regarding the demand for a product which has close to zero bugs? So in some kind of industries, such as, for example, the financial industry, manufacturing, logistics, they may have higher demand for zero defect software. Whereas in some other software, perhaps bugs are okay. And also, what is the demand for being able to deploy bug fixes quickly into production? Notice that I didn't say how quickly to fix bugs, no, but how quickly to fix and deploy them to production. Does it have to be done within a few minutes, an hour, a day? So the higher the frequency that you need to deploy bug fixes, it is pushing us towards test-driven development. Whereas in some other products, it could be okay to wait for weeks or months, depending to push bug fixes into production. And in that one, test-driven development may have lower motivation to use it. So the point is, if your legacy project is in these quadrants, then introducing test-driven development will have a high ROI. But if your legacy project is here, then I would say probably don't even bother introducing test-driven development. You might not get the benefit that you're looking for. So this kind of thing is really useful for technical leaders who are making these kind of decisions. This here that I illustrated is just two factors. There are also additional factors. So in the table above, we spoke about bugs and features and how that has an impact on whether TDD has a lower or higher ROI. But there are some additional dimensions which maybe not many people speak of. So team maturity. Is this a team which has both already some existing competence? So for example, are they competent in their tech stack? Do they know how to use refactoring in their IDE or something like that? Do they have certain level of competence, and do they have motivation for quality? In that case, it makes sense to introduce TDD. But if you have a team where existing competency, where some foundational skill sets are missing, and where motivation is missing, then in that case, it would not make sense to introduce test-driven development because it does require team maturity. Other aspect is also company lifecycle. So if it's a project that it's MVP or POC, whereby you can just make something and throw it away, it has a very short lifespan, it might not make sense to try best practices or TDD. But if you've gone beyond the MVP and your product has paying customers and especially in enterprise software, then you will get higher value. Another also aspect is, what is the cost of losing customers? So this means if it's very costly to lose a customer and to lose reputation, then there's a higher demand for introducing TDD compared to if you have a low cost. And the last one, budget. So in most companies, I would say budget needs to be used effectively. We can't just throw around money and spend it with developers spending 80% of their time on bug fixes. But who knows? Maybe there are some companies where there's unlimited budget and where they can waste money by hiring maybe hundreds of manual QA engineers to do regression testing every day. Then okay, then you can live without TDD. So that's the first part. Now, if there are any questions, feel free to go ahead or let me know if whether I should continue.
There is a question, or two questions. The first one is how to convince a team that they need TDD. What measures that you need to collect to prove that they need TDD? So I think you answered a few of these questions. And the second one is how to demonstrate to the management on the target state or the target measure that TDD has indeed helped the team.
Okay, these are excellent questions. First of all, how to convince a team that they need TDD? The team needs to have experienced pains of regression bugs. If they have not experienced any pain at all up to now, then I would not proceed to convincing them or even selling the idea of TDD. The kind of pains that I typically look for when interviewing and assessing teams before even starting technical coaching is things like, how many regression bugs do you have? How often do they occur? Is there any customer loss that can occur due to regression bugs? All of that, both monetary loss. How about your stress and pressure as you're trying to do deployments at the end of the sprint and your manual QA engineer is reporting to you bugs at the end of the sprint and you're trying to fix them and the manual QA engineer is trying to solve them? How do you feel? Do you see it as a problem? The team has to be the one, both the team and the technical leader must self-initiatively respond yes to those questions. If they don't, I do not proceed further. So after years of, for example, trying to convince people, I actually found that it has a negative effect. Don't convince. They need to have the pain point. And then if you see that they have a pain point, then we can proceed to, okay, there is a solution to that manual, avoiding manual regression testing. And then that's where there's that whole thing, difference between test last versus TDD, which is, okay, another topic. What measures do we need to collect to prove that they need test-driven development? Let's say number of bug tickets compared to number of user story tickets. Time logged on bug tickets versus feature development tickets. A very typical scenario is that a team might be spending 50% of their time on bug tickets, 80% of their time on bug tickets, and hardly delivering any features. So that is quite measurable, that whole ratio of bugs and features, both the number of tickets and the time logged. So that is one measure. The other also measure is a financial measure of customers who left the product due to issues of quality and due to having to wait too long for releases and updates. So those are some examples of measures. In terms of, I guess, more code and test metrics, we could look at measures like code coverage and mutation testing score, which evaluate, for example, mutation score is a useful one in evaluating whether our tests protect us against regression bugs. Typically, teams without TDD will have a low mutation score. low code coverage and low mutation score. So that is a metric regarding tests, and also metric regarding code quality. So for example, static code analysis metrics, cyclomatic complexity, code duplication, all of those kind of metrics will also tend to be low for teams who do not use TDD, because for them refactoring is unsafe. So there you go. I listed both the business measures in terms of features and bugs and these technical measures. How to demonstrate to management on the target state or target measures that TDD has indeed helped the teams. Here I distinguish between test automation versus TDD. The one that's an easier argument to make is about test automation and leaving TDD as second. So we can say that teams who have reliable test automation will be able to release quickly and safely. A very famous reference for that is, for example, the Accelerate book and all those DORA metrics. So essentially, the safety of releases and frequency of releases is directly related to test reliability of a test suite. Then, and that statement should generally be, acceptable. I don't think many people will debate over that statement. Then I go to the next statement. Okay, how do we achieve a reliable test automation suite? There's two ways. There's the test last development approach with mutation testing, and then there's the test-driven development approach. Those are the two alternatives. But that's I guess a bit of a bigger story. So maybe feel free, if we do have time at the end, to remind me to follow up on that one regarding test-driven development versus test last development.
Perfect. Thank you for your answer.
Okay. Great.
Yeah, you can proceed. We have a few more questions, but I think I will ask you at the end, because I know that you have a lot to say about how you should push TDD.
Yeah. All of these questions are great. So then, I guess the next one was related to some of these points in the previous question, the difference of on impact on feature delivery and maintenance cost if we have effective TDD versus no TDD versus ineffective TDD. I like to put here ineffective TDD as an option, because most people always compare TDD versus no TDD. But no one compares what happens actually when TDD goes wrong, which actually happens to be the worst option. And unfortunately, this is also what happens with those companies who try the 2-day training and then might try it in reality and then actually experience a disaster. So in any case, with effective TDD, the idea is that we can have a lot more time to spend on features, because we don't have to waste time on bugs. So if we're not wasting time on bugs, we are allocating it to features. So over time, we can deliver more and more features. If a team does not have test-driven development, so they're using test last, typically tests are written maybe at the end of the sprint, or at the end of the month, or at the end of the year, or most likely never. Then in those cases, initially things are fine when the product is small, but then as the product increases, that team has to spend more and more time on regression bugs, hence less time on feature development. So that's the case of no test-driven development. And then we have also the last case of ineffective test-driven development, which is actually caused by even ineffective test automation, and I'll get to it later, whereby the team does not have adequate skill sets and they are applying TDD in a wrong way, such that they are spending time on it, but they're not getting any benefit of it. So it's essentially just a waste of time and money, and that's the worst option. Then we also have the impact on maintenance cost. So in the case of effective test-driven development, over time, okay, as the product grows, we do have some, normal cost as, okay, your team is expanding and stuff like that, but the cost growth is quite controlled, whereby in the case of no TDD, the cost of development grows up very quickly. It grows up very quickly because your team has to spend all that time solving regression bugs. So you have to hire, so your existing developers might be spending 80% of their time solving regression bugs, and you have to hire additional developers because you can't get to the solving of regression bugs. So it's very, very costly. And then there's also the case of ineffective TDD, which happens when, again, TDD is introduced without adequate foundations, whereby a lot of time is spent on it, but it's not delivering any value. So this was the first part about the why. And now I'll get to the how, and especially addressing the case of how do we introduce TDD? How do we introduce it in a bad way? And how do we introduce it in a successful way? So the most common way to introduce TDD is the bad way, which is the case where it will basically fail. So it's essentially that story that you started with at the beginning of this webinar, the case that companies may send their developers to, let's say, a 2-day TDD training. So the company is immediately jumping to TDD, but there was no checking of any prerequisites. It is similar to the case of going to the doctor and they just prescribe you something without actually checking all the, how shall I say, background history. So what happens here is that companies decide, whether for training or some other methods, to just jump onto test-driven development. And what happens is test-driven development is then not done properly, and in the end it fails. So you don't get reduction in bugs, you don't get speed up in delivery. In fact, you actually get worse. You can even have more bugs. You could have even delivery slowdown due to TDD when it's applied wrongly. And developers are demotivated. And then everyone says TDD doesn't work and we will never try it again. And that's it, like end of the story. So this is what many companies do because they heard of TDD. But here I want to illustrate what's actually the proper way to introduce TDD. And as you can see, well, it's not so quick. And later we will see also why it can't be done within 2 days. First of all, starting from the foundations, the pillar here is psychological safety. So it's about the team feeling safe to work together and to open up about problems and to be open to learning. So if that doesn't exist, well then, sorry, you can't introduce any technical improvement at all. So this is really core foundations. Then we also have basic skill sets such as tech stack. So for example, if a team is working with Java, how good are they in using, Spring, or using, for example, .NET framework, or whatever is the tech stack? So can they program out adequately a REST API? And so here I'm not talking about hexagonal architecture or anything. Like, can they just get a basic working product that they can implement a REST API, databases, message consumption, message publishing, etc.? Are they also familiar with object-oriented programming paradigm? Another one is also functional programming paradigm. So for example, in object-oriented programming, does the team know about encapsulation, polymorphism, etc.? So all of these essentially technical foundations. And these things are needed, especially the tech stack and REST API parts, to even get working software. If this foundation is missing, if your team is struggling with the tech stack and struggling with how to use the IDE and doesn't know about, let's say, IDE refactoring shortcuts or other inefficiencies, that needs to be solved first before moving onwards. Okay, assuming that both of these have been satisfied, and this is why team should always do an assessment before even embarking on any sort of coaching. Then if these foundations are here, and assuming that the team also has motivation to learn how to make maintainable software, not everyone has that motivation. The team might be happy working just in this and not see any problems. But if a team is mature, they see, well, there is always room for improvement. And this is where we focus on how to build maintainable software. And here I wrote about test last development, so doing it in a test last development way. So, and indeed, this is really important because on a legacy project, especially big ones, a lot of effort needs to be spent on this test last development approach because you have to retroactively introduce practices. So we would need to introduce testable architecture, hexagonal architecture. That's a prerequisite. So test-driven development involves writing a lot of unit tests in a test-driven development way. But to write unit tests, you need to have architecture which allows unit testability. So you need at least hexagonal architecture, or you can also have derivatives of it like onion or clean. So notice how this is foundational. You can't just jump onto TDD. There also needs to be effective test practices. So here I'm talking at all levels. So unit level, integration level, component, and end-to-end level, which means retroactively, we need to look at existing tests and talk about how do we improve the effectiveness of the existing tests. The question is, what is actually the primary purpose of these tests? The primary purpose is to protect us against regression bugs. And if our existing test suite is not protecting us against regression bugs, then it has zero value. And I found that to be actually a very, very common issue faced by many teams, that their test suite basically has zero value. Now, in order to solve it, we will talk about it like, okay, what are the steps to get to effective tests? But that's foundational. The other part that is also foundational is how to write effective code. So understanding clean code, code smells, refactoring, and doing all of this on the existing code base. Because how can you improve code with refactoring if you don't know what clean code or effective code looks like? So all of this is done on existing code base so that the team has key skill sets in how to write effective tests and effective code in a test last development approach on the existing software. Then when all of this has been accomplished, then we can move to test-driven development. Test-driven development will, as we mentioned, it requires the existence of a testable architecture, and we will use these same skill sets, writing effective tests and writing effective code, except we will just be switching the sequence. So instead of writing code first and then the tests, we will write tests and then the code. And instead of doing it in batches, like lots of code and then lots of tests, we will do it incrementally, essentially test then code, and of course having all those minor refactorings. So here, this iceberg image is illustrating that there's a lot below the surface that needs to be there before we can even introduce TDD at all. And now I want to talk a bit more in detail in terms of this transformation. So typically we are
we have a few questions, but I think there is one which is really important right now. Marwan said that, as I understand, you cannot implement TDD without hexagonal architecture or clean code. But you spoke about different kind of architecture, but then you mentioned clean code as a key success factor.
Oh, okay. So here we have two aspects about architecture and clean code. You can have hexagonal architecture and dirty code inside. You can write unit tests on top of it. I mean, the sociable unit tests, which are, for example, targeting the driver ports. So in that case, you can succeed. Okay, you have the architecture there. You have tests, and those tests are protecting you against regression bugs. But if you have dirty code, the problem that you face is that your cost of change is still high because code is unreadable. So you need additionally clean code to essentially to make it easier to make change. So just to summarize, the point about hexagonal architecture or onion architecture, clean architecture, that belongs here. So that's a prerequisite for testability. And then this part is about good tests and good code. So good tests is about reducing our maintenance cost by protecting us against regression bugs, whereby clean code is about reducing maintenance cost by writing a readable code. And if we achieve all of them, the reason why I wrote both of these as prerequisites is as follows. Testable architecture is a prerequisite to even write unit tests, whereas effective tests and effective code is a prerequisite because TDD cycle involves writing tests, writing code, and refactoring to clean code.
And so there is another question. We spoke about hexagonal architecture, but functional architecture or other kind of architecture, is it possible to implement TDD on that?
Yes, so hexagonal architecture, it does not prescribe whether you'll be using object-oriented approach or functional approach. You can use either approach.
Okay, perfect. I let you proceed.
Okay. Great, thank you. So we typically start off with a CRUD application, big ball of mud. And then to transform it, there do need to be some, okay, so it's a big ball of mud, so we can't even write any unit tests. And then that's the problem. How do we even introduce retroactively unit tests with a big ball of mud? The only thing that you can do with a big ball of mud initially is approval testing. So these are essentially wide-spanning tests that might be targeting your REST API and hitting the database and hitting anything else externally that exists, but just to capture the existing behavior. These could be done via approval testing tools, or they could even be done by talking to business and essentially formalizing the most high value scenarios and writing tests for these ones. So these are essentially wide spanning tests. Then when we have that basic protection, then we can move into hexagonal architecture. So this means splitting code that does business logic from infrastructure, but not refactoring, not changing any of the business logic. So examples are, if you have a REST API controller and it has business logic, cut and paste it into application services. So that's a cut and paste procedure. If your application services are talking to some external REST API or database or whatever, cut and paste that code to separate classes and introduce interfaces. So this is sort of cut and paste operations involved here because we want to do the minimum. We're doing the minimum because we want to avoid risk. Then when we have this minimum, then we're able to write unit tests, integration tests, and component tests. So unit tests in hexagonal architecture, they target the application, the hexagon. We can use firstly mutation testing to help us increase the effectiveness of unit testing, protecting us against regression bugs. This is really mandatory because if your tests are not protecting you against regression bugs, we can't do any refactoring. Any refactoring is unsafe. So on a typical legacy project, the mutation testing score might be really low, like 20% or 30% of code where essentially for the mutation score. We need to get it up to 100% score to say that region of code base that we can refactor it. So this is the purpose of mutation testing. And we also need to look at unit test readability. So are the unit tests expressing behavior? When we have both of these, this means that we can trust our unit tests, and then we are able to refactor the application. Here, when I say application, it's in hexagonal architecture, the hexagon. A similar thing is also for integration tests for the adapters, but this is generally a much smaller subset of tests. So here is where most effort goes, and here is where there's less effort. You may or may not use mutation testing here. And then we have the smallest piece, component test. So this is in the case that you have microservice architecture, and you're using hexagonal architecture inside the microservice. So you have unit tests for the hexagon, you have integration test for the adapters, and component test is essentially sort of like an end-to-end test for that microservice only in isolation from all other microservices. This is the essence. Additionally, you can also do adopt clean architecture. So it's like the next step after hexagonal architecture. The main difference is that hexagonal architecture does not prescribe to you how you're going to organize, how you will organize your hexagon, but clean architecture does. Clean architecture specifies that you need to have use cases and that you need to have a domain, and that the domain needs to be rich. So I put it here as an optional step. All the thing below is necessary for TDD. This thing is a nice thing. It is not mandatory, but it is nice to have it more from, I guess, domain modeling and use case modeling perspective. In any case, notice after all of this effort here, that then this is this part of the iceberg. The fact that we've introduced the unit tests, and the other tests, and that we did refactoring, and that we have hexagonal architecture, that's that minimum above. Then we can move on to test-driven development. All of this here was essentially test last. Okay, I'll just change the font. All of this was here test last development. We were applying it retroactively on existing code base. Whereas now we move proactive, test-driven. This is when we take real stories from the sprint, so user stories and bug tickets, and do them in a TDD way. We are using the skills that we gained here, but we are reversing some operations, such as doing tests before code and doing it incrementally, which means test code refactor instead of all tests and then all the code. So that is the process. The other important thing that I want to illustrate is someone can say, but our project is so big, even this could take years to achieve. What do we do then? Well, during coaching, at least sharing what worked well for me, is when illustrating this, we do not do it on the whole code base, but we do it on a subset of the code base, most specifically choosing things that are high value within that code base. So certain functional segments of the code base which have a high business value, and demonstrating this whole flow on that subset of the code base. So this is what I tend to do during coaching. The team, based on what they've learned on that subset, then they can replicate this on other parts of the code base. So that's how you get incremental transformation without blocking everything. And then the last part that I wanted to present before we get to the a few more parts here, and then we'll get to the, I guess, the questions. This one is a bit more technical, and notice here how I'm still only talking about these foundations, not even the TDD part, just to illustrate how much is involved. So if you have a microservice architecture, so for and then per microservice you are applying hexagonal architecture, you will have the application, the hexagon, you'll have driving adapters, driven adapters, and then you'll also have test doubles also to substitute for the driven adapters. For unit tests, your unit tests are targeting the application at the driving ports, and you're using test doubles instead of real infrastructure. For integration tests, you are targeting, you have integration tests for the driving adapters and for the driven adapters, obviously separately. And for the driven adapters, the same test would also be run against your test doubles. But notice we are not testing the application because that was covered by unit testing. So this is the majority of tests, this is minority, and then the fewest tests will be component tests. They span the whole microservice. So you do this for every single microservice. And of course, having a pipeline, so notice didn't even mention the word pipeline above, but of course you need to have a pipeline per microservice so that each microservice is independently tested and deployed. And on top of that, you also need to have end-to-end tests, which test your whole system, like front-end, API gateway, microservices, third-party systems. And here, this is an illustrative image whereby I've drawn a microservice zoomed in, which has the application. So that's the application, the hexagon, where we model the use cases and domain. We have driving adapters, for example, REST API, message consumers. We also have driven adapters, such as persistence to database of files or publishing to message queues. And we also have test doubles, which substitute for the real adapters. And here, well, it's essentially this same table, just illustrating what is the span of each of these test types. And we do this for all the other microservices. And we also finally have end-to-end tests, which target essentially the whole system. Now, this image is something which I did explain in a lot more detail in one of previous meetups, so maybe I could also share a link later to that meetup as well, whoever is interested more in the technical points. But the reason why I wanted to illustrate this is because all of these skill sets are related to these foundations. And then TDD is just the process that comes on top. And then we come to the point of how do we actually introduce all of this iceberg? Do we introduce it through training or do we introduce it through coaching, and what is the difference? So, starting with the most typical scenario, what most companies do is the TDD training option, which means they have a 2 to 5 day That's the typical duration of TDD training. And in that training, the trainer is using a demo project to illustrate TDD practices. Some trainers might use completely made up katas like FizzBuzz, whereby it has no connection to reality, but some trainers may use a bit more realistic projects, like maybe making an e-commerce app or a restaurant booking app or something to illustrate TDD, which is a bit better, but it's still a demo project. The question is, what happens? And everyone is excited. Let's say they are excited during the TDD training. But the question is, what happens afterwards? One of the problems with training is after the training, that's the end. The team is left alone. They have no feedback on the real project if they even attempt TDD. Now, we have two options what can happen. The most common scenario is that after the training, the team will not apply TDD because the trainer was showing TDD on a demo project, not the real project, but the real project is much more complex. So that's one difference, complexity. The other reason might be that the trainer has shown a clean greenfield demo project, which is the most typical way of showing it, but not steps to introduce TDD into a non-testable legacy project. So even though the team has seen on a simple example how to do TDD from scratch, they do not have, the trainer did not go, I'll just illustrate here what the trainer did. So the trainer showed this part, effective TDD, on a simple demo project, but not the real project. And the trainer may not even have shown how to achieve this on a legacy project at all. So the team does not see how they can apply it to their non-testable legacy project. So this kind of team says we cannot apply TDD in real life. TDD works only in trainings. TDD only works in conferences and books. And that's it. So money was spent, but there is zero value from that money. We also have the cases of negative impact. And this is something that not many people are actually aware of. This is the case that the team, after training, does try to apply TDD to the real project, but it is quite likely that they are applying it in the wrong way. And when they're applying it in the wrong way, that's when TDD becomes expensive without actually any benefits. And this team does not even have any idea that they are experiencing problems of using TDD, but they have no idea that it's caused by the fact that TDD is applied in a wrong way, and they have no feedback, because that's the whole thing. There is no feedback after training on the real project. Then we come to the option of TDD coaching. Now, TDD coaching is about working on a real project, so not a demo project, but on the team's real project, working in a very regular and incremental way. And during TDD coaching, on a legacy code base, I help the team firstly to achieve these competencies on the existing code base before even moving to TDD. And it's done very, very incrementally and step by step. So the idea is that during coaching sessions, we would introduce a new practice, so whether it's introduced in the testable architecture or about effective tests or about effective code, and applying it on a subset of the code base, a subset of the test suite of the real project. And after coaching sessions, developers would continue to apply that practice to the real project. And then during the next coaching session, I would review what was done and then adjust and repeat. So the team is getting continuous feedback in order to be able to practice practice effectively. Here, the coaching approach tended to have positive impact because this is small, consistent change over longer time periods. So the team is progressing, but we're also not blocking delivery and stuff like that. The team gets a transformation, and this quality now starts becoming practice. And we essentially go through the whole iceberg during coaching. This at the bottom is a prerequisite before even starting coaching, but then during coaching we go through this, we go through this, we go through this, and then when we see the team is applying these practices effectively, then we move on to effective TDD as well, and applying effective TDD on real user stories and real bug tickets. So this was just a very short overview and of the whole process involved in coaching.
Thank you, Valentina. So now we saw that it's really more complicated than maybe what we thought about just writing tests before writing code. It's really interesting, those first steps that you need to achieve. And we have a question about this one from Quentin. Hexagonal architecture is not something simple. By jumping from the pile of mud to Hexa, do you need to create some tests before starting to change the app architecture to avoid damaging the app? And what kind of test do you write when you make this transformation?
Excellent question. Yes, definitely it is not simple. I mean, if it was simple, we could do it in one day and it could be a training session. In any case, it is not simple, and there is that difficulty of how do we jump. And this is why we need that step of approval testing. So a big ball of mud, even though we can't write unit tests on it, we can write approval tests. So the idea is that we need to capture the behavior of the existing application, or at least important behaviors of the application before we proceed to changing the architecture, because any change, including the change to hexagonal architecture, can introduce regression bugs potentially. So we need this approval testing. This can either be done via usage of approval testing tools, which is a whole beyond the scope of this webinar. So feel free to research about approval testing. Or we can also, the developers can, for example, look at any existing test scenarios that were written by the QA engineer or something like that and write REST API tests. So this means if you have a microservice and inside it's a big ball of mud, you write tests targeting the REST API, and that a microservice may also be connected to a database. It may be connected to some other external systems, and we can have a very wide spanning test covering all of that. Because then when we start making this move to hexagonal architecture, we can then run our approval tests to see whether we broke something. And even here, as I'm moving to hexagonal architecture, I try to encourage the team to do bare minimum. For example, not allowed to improve the code at all. In this point about hexagonal architecture, only should do cut and paste operations. So that is yet another further risk reduction mechanism.
So you use mainly your IDE to extract some components and to move.
Yes. And before I go into more detail on that, I just want to say here in this response how it was written, like making some integration tests to be sure the logic is kept. Yeah, so as part of your approval testing, we can refer to them as very wide-spanning end-to-end or integration tests in some classical notion. And now regarding Arthur's question, yes, it is more productive to do it via IDE tools instead of manually doing cut and paste. And here I just want to name a few common operations that I like to do in the following sequence. So in the biggest ball of mud, you have a REST API controller and everything is in the REST API controller. So first step is cut out a lot of code away from the REST API controller and copy paste it into new class, which you call an application service. So if you have an order controller, you make a new class order service, and you cut and paste code from the controller into the REST API service. So doing that here, cut and pasting from the REST API controller into the application service, so that the REST API controller has only the HTTP request, the HTTP response, and it delegates to the application service. So that's a cut and paste operation. Then the next cut and paste operation is when your application service has direct calls to, let's say, direct HTTP call to PayPal, or direct, I don't know, call to stored procedure on some ERP. To replace those direct infrastructure calls, but we're not doing DDD modeling at all. We do cut and paste of that code, which is calling database or calling web service, cut and paste it into a separate class and introduce an interface which has retaining the same method signatures. So those interfaces are actually badly modeled because we're not changing modeling. They're badly modeled, but we've done actually the minimum to be able to at least write unit tests.
There is a lot of question about hexagonal architecture. I think a lot of teams has not implemented yet hexagonal architecture, and you said it yourself. It's hard to implement it with a lot of people in the team with a legacy project. So we have another question. Is there a risk that applying TDD in majestic monolith like MVC application could be less effective or become problematic over time? And there is another question within the chat saying that maybe you could apply TDD in other kinds of architecture, but you said it yourself. But what are the real prerequisites, the real thing you need to have within your architecture before applying those tests?
Okay. So first of all, in terms of whether it's monolith or microservices, that part was not a big decision-making factor, at least for me. So in both of those, that was not the key deciding factor. The key deciding factor is, I would say, well, not about TDD per se, but I would say what's the value of unit tests, unit testability, because a key motivation why we want to apply a hexagonal architecture is unit testability. And the question is, what is the value of unit testability for us? In an application which has a high business logic complexity, so I've seen it in financial domains, logistics, where there's so many finances, calculations, all of that, the higher the ratio that we have of business logic, the higher the value of unit testability itself. And then when unit testability has value, it forces us to adopt hexagonal architecture, because hexagonal architecture is the minimum for unit testability. And then we have that whole topic of whether to write unit tests in a test last versus TDD way, which is a separate discussion, but that's one route. So notice here how the key argument was not TDD, but actually the need for unit testability. However, if you have an application whereby the business complexity is very low, and that all that your application is doing is CRUD operations, so add to database, edit, and there is no complex validation. There aren't many if-elses. There aren't any calculations, which is the case for many, startups. And when it starts, it's always simple. It's always a simple CRUD app. Then in that case, it could be quite reasonable to continue with your typical traditional integration tests, whereby you write the test targeting the REST API and it hits the database as well. And you're not writing any unit tests, and then you have no need for hexagonal architecture at all. And that is actually the case for many projects in the early phase of development. But over time, as business complexity grows, that's when the need for unit testability grows. And that's when the pains of not having unit tests are there. And that is why I tend to work with teams who already went beyond that point and they are facing the problems. If a team has not yet reached that pain problem, then there isn't much motivation for unit testability.
Yeah, I think you answered another question, which is just asked within the chat. Today, we see a lot of projects with hexagonal architecture, but those are projects which didn't need this kind of architecture because it was really simple projects. But what you said, it's more about a unit testing versus integration tests. And if you need to have those unit tests on business logic, is because your business logic is complex. And
correct.
Yeah, and then you have to extract it. Yeah.
Yeah. So the point is, I don't introduce hexagonal architecture for the sake of it. The main benefit I see of it is unit testability. It enables us unit testability of the business logic. Now, as you mentioned, in projects which are currently very, very simple, as in all that they're doing is CRUD operations, which is the case in early life cycles. So when a project starts in the first few months, first 3 months, maybe first 6 months, it is exactly like that. Then if you introduce hexagonal architecture to it, most likely developers will complain. They will say, you've now introduced a whole heap of interfaces and made it unnecessarily more complex. We don't see the benefit of it, nor do they see benefit of the unit tests at all. So the value is not there. Now, even though they will get value later on, because the business complexity will grow over time, but right then they don't see the value. Whereas a team which has reached the business complexity without hexagonal architecture, they are the ones who are recognizing the pains. So my recommendation is actually to feel the pain first, and then everyone will be more receptive, both the leaders and team, towards how to solve that pain. Don't introduce any of this if the pain is not there.
Yeah, I think that's a good argument. And that leads us to another question. How you should encourage other developers within the team that actually always suggest against test-driven development.
Yeah.
Maybe they didn't feel the pain of it, or maybe they just didn't know about what is really test-driven development and the benefits of it.
Mm-hmm. Exactly. What I do there is I actually move away from the discussion of TDD and avoid, I mentioned this as maybe a side point, I focus on test automation, which is the part that they will accept. And then when I speak of test automation, then I say, let's run a mutation testing tool against our existing test suite. And then mutation testing reveals a low score, indicating that our tests are not protecting us against regression bugs. And then we can, via mutation testing tool, retroactively go and look at that uncovered part of the code, retroactively write tests, which is a very boring, very time-consuming, and very demotivating process. Then, after I've done that exercise with the team, so there's no mention of TDD at this point, we're just doing test automation and, improving, making sure we're protecting against regression bugs. Then I say, we can continue in this way, and indeed we can. You can continue test last and mutation testing, but there is also another way, and that other way is TDD. So applying TDD will give us equivalent results to doing test last plus mutation testing. When I say equivalent, I mean equivalent in terms of practically equivalent test suite reliability. And even Uncle Bob says it here, the article about test last and mutation testing. No, they are equivalent. And then I say, let's see which approach we will prefer. And then, so after doing test last and mutation testing and feeling pains of it, mutation testing, then later trying out TDD, but I say we're not going to adopt TDD, we will just try it, and then we'll compare the difference. Most people, after going through the mutation testing scores, will lose the motivation for it, because TDD will immediately give them, how shall I say, the benefit. All of this it's not done in a 5-minute argument. This takes months to achieve. So, and indeed, I am working with seniors on teams where the team is split regarding their perspective on TDD. But that is why, even it's part of coaching, this is my biggest focus, and here there's no TDD. And then we do TDD, and then they can see what makes sense. They can continue with this and mutation testing if they want, or they can work with TDD. So it takes, how shall I say, several months, and showing an example is way more powerful than any theoretical argument.
Yes, we had another webinar about coaching craft within the team and pushing software craftsmanship and a lot of different methods about clean code, etc. within large companies. And we said the same, that the better things to do is to present an example of what are the gain and what are the pains, and then to push those solutions, and not to start with solution to a problem that the team didn't have yet. So it's really interesting how you have those steps to push TDD.
Exactly. So here, and the point is, in the end, I don't tell the team the benefits of this. They tell me, when we do comparison, I ask them, okay, let's compare it. Now that you've done test last plus mutation testing, and now that you've done also TDD, which is the equivalent in producing a reliable test suite, let's now compare. And let's see what you would choose. So in the end, that's the whole point about mindset transformation.
Yes, that's really interesting. And we have another question. I think maybe the last one, because we are running out of time. Yeah. When you are starting a new project, you say at the start, maybe you don't need hexagonal architecture. Which architecture could you implement at first that could help you to switch quickly to hexagonal architecture after you reached a kind of big complexity within the business?
Okay, great. So I'll give multiple answers here depending on the circumstances. We have two cases. We have a team that is already, let's say, already has experience in hexagonal architecture and TDD, etc., which is very few people. And for example, on LinkedIn, Mikel Azerad, when he writes about how he makes projects for startup, he starts with it right away. So a person who already has competency team would start right away, even though it's not needed, but they start right away because they know in a few months complexity will grow, and they don't want, and there's no need to then ask the manager for permission to refactor architecture. So that is the case for starting right away. Either the team already has done it, or a team who has gone through coaching and has succeeded on it. Then for the next project, they will most likely actually choose to even start with hexagonal architecture right away, because it will not be a burden for them. So that's the case of starting right away, but that's very, very few teams. For majority of teams in the companies they worked with, they've never seen this, because most companies are not practicing it at all. It's completely new. In that case, for most teams, what makes sense is you start with a typical CRUD application. So there's no hexagonal architecture, but then at some point the team will most likely need to then get management approval. Well, that's the way it works in big companies, to refactor their architecture to hexagonal architecture. But once again, I would recommend not doing that, not switching to hexagonal architecture, unless there's already a person in the team who has done it before and who is going to internally coach the team, or hiring an external coach. Those are the two valid options I see. If the team with no prior experience tries to experiment this on a production project, it will fail, and then management will blame the team. So that's the option which I essentially suggest against it. So I guess my answer was a bit maybe broader than this.
Okay, thank you for your answer.
Great.
We have maybe last one.
Yeah.
You spoke a lot also about hexagonal architecture. Can you suggest good books or good references?
Okay. So unfortunately, currently, in terms of books, there exists a book on clean architecture. But regarding hexagonal architecture and onion architecture, there mainly exist blog posts. I mean, for example, Alistair's post regarding hexagonal architecture, but no official books. However, there is a book in progress, but there is one useful website which was done by Juan, who was also a speaker at my YouTube channel. So maybe I can share his website, because his website is actually a very, very comprehensive, almost like a book, and I found that to be the best interpretation of hexagonal architecture. So I could share that link.
Okay, perfect. Yes, you can share it. I don't know if you have it right now. You can share it directly within the chat.
Okay,
or maybe...
1 second. I will do a search. Please wait 1 minute.
Okay. And during this time, I will share my screen just to present the next webinar that we will have. So next week, we will have Manon Carbonel. We will talk about, in French, about good practices in front-end and web integration to ensure the quality of our application. And in 2 weeks with Christophe, we will speak about clean archigonal. So it's a mix between hexagonal architecture and clean architecture. So it's really related to this subject, but we will go deeper within this clean architecture and hexagonal architecture part directly. Up. Stop. Up. Thank you for the link, Valentina.
You're welcome.
Thank you again, Valentina, to speak with us today and to explain all of those things. Like you said, this Miro link will be available for everyone. It's already within the chat, but we will also share it on our LinkedIn page and on our YouTube channel. Thank you everyone for joining here today. See you to the next webinar.